Okay, I'm going to kind of end this discussion by talking about guessing the right value of a sequence. Okay, so let's say that you have the first n terms. What is the actual sequence? Okay, now I hate this game. Okay, because I always feel that a legitimate answer is, well, that's a1, a2 up to an, and then 0, 0, 0, 0, 0, 0. That's a perfectly fine sequence, isn't it? So what am I supposed to do? Read your mind? But in some cases, you can kind of, by inspection, kind of find a rule and go, okay, fine, that's what you mean. Okay, so this is what I do. My first step is I try to look at the differences between elements in the sequence. So what am I doing? Is it an arithmetic sequence, right? Because arithmetic sequences come up a lot, right? So I might as well check if it's an arithmetic sequence, okay? Then I check the quotients or the ratios. I'm asking, is it geometric? Right? And that's a hope, right? Okay. Okay, neither one of those happened. So now I'm going to check to see if there's some kind of a repetition. So for example, is it 1, 2, 3, 1, 2, 3, 1, 2, 3. Okay, I see the pattern now. Okay, that's really what this is about. Okay, does it have repeated values? Well, what I'm after is 1, 2, 2, 3, 3, 3, right, and so on. Something to tip me off that that's what's happening. So I'm going to look for places where it's repeating. Okay, and then it's a little bit of desperation. Okay, but basically what I'm saying is, okay, it's not any one of these obvious things. So let me see if I can come up with a rule where I say a sub n depends on a sub n minus 1 and a sub n minus 2 maybe. Maybe it's a sub n minus 1 and a sub n minus 3, right? You know, just something to see if it works. And so you're combining things, adding them, multiplying them, subtracting them, and you're hoping that that gives you the result, okay? So that's advice. That's not very concrete. Let's actually look at an example, okay? And so we have a sequence here, 1, 7, 25, 79, 241, 727. Is it obvious what the sequence is? Again, if your answer is yes, I am really impressed, okay? I looked at this sequence and I go, what? Okay, there's nothing. I mean, I got nothing. So when you have nothing, then you use the techniques, right? You know, that's what they're for. If your intuition lets you jump by leaps and bounds, jump by leaps and bounds, okay? If it doesn't, right, then use the techniques to kind of get you there. So yeah, it didn't work, so let's try. So what I'm going to look at successive differences, okay? So 7 minus 1 gives me a 6. 25 minus 7 gives me an 18, and so on, right? Okay, so I was really hoping that those successive differences were all the same value, but they're not. That's not very promising. I am not panicking because I got, 5 other hints, right? So let's try. Let's try differences of these differences. You might as well, okay? It's because it's like, yeah, that didn't work, but don't give up, right? Just try stuff. Next thing that I could have tried, incidentally, is 18 divided by 6. 3. 54 divided by 18. 3. 162 divided by 54. 3. Right? So yeah, the problem is that I'm looking at the successive difference sequence. So you see that there's a pattern there, right? And that's why you just have to keep trying. Okay? So yeah, if I look at successive differences, 12, 36, 108, 324. 12 times 3, 36. 36 times 3, 108. Yep, I see a pattern. Okay? All right. Now, once you have that, I still don't have a closed form solution, but I'll tell you what I have right now, which might be almost as useful. What's the next term in the sequence? I can figure that out, right? Because let's see, I know what the next difference ought to be. Once I know what the next difference ought to be, I add it to the last term that I know, and that's the next term in the sequence. So you see, I've actually discovered useful information already. Okay, so we looked at, well, let's look at this this other one. Okay, 1, 7, 25, 79, and so on. Successive quotients. 7. 3.57, 3.16, 3.05, 3.02. It's not perfect, okay? It's not perfect, but it's just a little promising, right? It's about 3 times the previous one, and it's getting stronger, so I'm a little encouraged. So here's what I have. I have a guess that 3 to the n is a possible solution. It's just a possible solution, right? It's obviously not correct. So let's see how off I am. Because I look at 3 to the n and I see that's 3, 9, 27. Hey, look! This is always 2 more than my original sequence, which means that my original sequence is actually 3 to the n minus 2. Now I have a closed form solution. Okay, so back up a couple of steps. When I started, right, I tried successive differences. That didn't look very promising. I could have tried successive quotients of the successive differences. That actually was very promising. I looked at differences of the differences. If you're thinking second order derivative, you're on the right track. Okay. If I look at those differences of differences, then I see a pattern. Okay. So basically what that's telling me is that, yeah, you know, I mean, it's, it looks like the second order the derivative is going to be something like 3, right? You know, 3 times, right? You know, that seems to be the case. Okay. With this, I was not able to find the answer, but I was able to get close. At least I was able to generate the sequence at will. Okay. Now this way, I was actually able to rebuild it. Okay, completely. And that's what you do. You just try different ideas until one of them works.